Hey, what's up, everybody? Today is February 17th, 2025. Another day to try and do Leetcode problems. We're going to go ahead and try and do the daily, but before we do that, let's go ahead and warm up our fingers with some practice on Type Racer. Okay, a rogue does not laugh. Hypocrite does not shed tears of a man of good faith. All falsehood with a mask. Farewell may be mask, maybe with a little tension we may always succeed in distinguishing it through face. 102 is okay. Triple digits is always good, but I'm really wanting to hit the faster numbers. And I think once the temperatures start warming up, then my ability to type faster might get faster or they get worse. I don't know. Temperatures do weird stuff. But let's go ahead and check out the Leetcode problem of the day. 2375. Construct smallest number from DI string. Oh, reset. Confirm. Okay. Well, obviously done this problem before. Excuse me. I've obviously done this problem before. When did I do it? Oh, I've done it twice. 23 and 22. You are given a zero-index string pattern of length n, consisting of characters I, meaning increasing, and D, meaning decreasing. All right. A zero-index string num of length n plus 1 is created using the following conditions. Num consists of the digits 1 to 9, where each digit is used at most once. If pattern I equals I, and nums I is less than nums I plus 1, if pattern D is okay, return the lexicographically smallest possible string num that meets the condition. Smallest. Okay. Let's look at the first example. I, D, D, D. Okay, so we need increasing values for the first three values, right? One to two is increasing, 2 to 3 is increasing, and 3 to 5 is increasing. So something like this, 1, 2, 3, 4 is increasing, right? Then we need a decreasing value with 3, then an increasing value, 4, 5, 6. Okay, and we need values 1 to 9, right? Oh, I'm sorry. This is decreasing values. So 1 to 2, 2 to 3, 3 to 4, 4 to 3, 3 to 4, and then 4 to 3, 2, 1. Okay, so 4 to 3, 3 to 2, 2 to 1, 0. Well, okay. Wait, hold on. Increasing is 3 to 4, 4 to 3, 3 to 2, 2 to 1. Okay. So if we do this, okay, Length of 8. This, okay, length of 8 immediately yells backtracking. I guess this is kind of similar to the problem we did yesterday as a backtracking problem, where we just find everything and then see if it is valid. Right? We're looking for lexicographically smallest. Okay. Now I could use a set, or I can use a vector bool. Taken. It's going to be 1 through 9. And we're never going to use 0, right? I could just say 10 and then do the values 1 through 9 because it's going to be zero shifted. So false. I wouldn't even have to worry about it really. Right. Now I want a copy of it for each one. And then we just want to go through the 1 through 9. We want to try the value, or the string, which I'm going to say string result. Okay. Yeah, so we're always going to try the smallest first. And then once we found one, we can just say return true. And we'll say if taken I continue, taken I equals true, we are going to then say result.pushback. We're going to push back I. And then we want to go BT IDX plus 1, go to the next spot. Then we're going to go, this is actually pattern.length plus 1. Right? BT IDX plus 1 taken result dot push back I, or I'm sorry, pop back taken I equals false, BT IDX plus 1 taken result. Okay, so this consists of those. Let's see. If I say I, then this and this needs to be increasing. If I say 0 in the next one. We don't want to push back to result. What we want to do is say if result dot length. We need two values to compare first. It's greater than right. Then check if they're increasing. And wait, how would we do that? Let's go this route. If pattern IDX equals I, right? This and the next one. Yeah. Like this. This is I think I got this backwards, but whatever. This will return false. Either that or keep going. True. Done. Results. This is my backtracking here. And then if this return true, let's keep going. If this return true, right? I know. Okay, BT 0 taken result. I don't know if this is going to work, but we will see. Non-void lambda. 1, 2, 4, 3, 6, 5, 7. 2, 3, 4, 5, 6, 7. 7 numbers. What? Pattern IDX minus 1. Maybe this should be pattern IDX. No, it should be minus 1. Maybe it's 2. And the current value we're on, which is IDX minus 1. Say we're on 2. So we put a character. So there's no characters. It starts at 0. We put in a first character that goes to 1. Right. So this needs to check. Oh man, I don't know. Minus like 3 or something. Or maybe I should just do a for loop once I've found the 9 characters, then backtrack. But I want to cut it off beforehand. So if it equals 2 characters, 2 characters in there. Right? Then this is technically we're on IDX equals 3. Okay. Oh, no. What? We push back the result. IDX plus 1. Given a pattern. How could this possibly be breaking right here? First character. Okay. 1 through 10. Taken. Zero through 9. Okay, so 1 through 9. It's fine. Oh. Okay. It only ever goes 6 and 7. If IDX equals an 8. Maybe you're supposed to be greater than or equal to 9. So I get to 8. And result dot length should have pattern. Well, this should be pattern dot length plus 1. Right? Not 9. And IDX should be for pattern dot length. Okay. Okay. I don't know if this is going to work completely, but let's go ahead and try it. Time limit exceeded. Goes to 10. 1 to 8 values. Oh, hold on. First off, I don't need 10 values. I just need length. So that would be 3 plus 1, 2. So this should be 5, right? So if I have this as 3, this actually sets to 5. Okay, that's still TLing. Why are you TLing? Hold on. No. Let's see. IDX is 6. Hmm. One of my numbers are off. That's true. I feel like technically I don't need this. Right? This should be +2 at least then. Is it this that's killing it? So these two are still working, right? Okay. Runtime is 255. But somehow I need to check in here if it's valid. Right? This might not work the way I wanted to. If taken, continue. I need a faster way to identify which ones don't work instead of this for loop, right? If IDX is greater than 0, if pattern AX minus 1, I Okay, so if we have an index, say if we're on 1, right? And result length is greater than equal to 2. I'm assuming. Wait. Hold on. If I pop back, I need to do this. Or maybe not do this at all. Hold on. I think that's where I was breaking. Yeah, because I was proceeding with an empty string. I don't think that was going to work at all that way. Hold on, my backtracking sucks. Anyway, so you do something, you go to the next value, you pop it, you try the next value, blah, 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 blah. If it doesn't work, return false. No, 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 no. Okay. There's no C outs now. 3. Significantly faster. Okay. Okay. Wow. Okay. That was a slow solution. Look at this. Every 67% of people got such a high mark. Why is mine so slow? I think it has to do with this for loop. So I was originally going to check to see each node is valid instead. And if you ever find an invalid node, just return false, right? Let's see if I can do it. I'm going to give myself a few minutes, see if I can get myself to make it a little faster by checking each individual node before I do something else. All right. So if our result dot length is greater than equal to 2, we officially have 2 values that we can confirm if it's valid. Right? So if I'm at IDX, okay, so if I put, okay, I start at 0, index 0, right? I push back a value, and in this value, I increase the index, and then I go to the next one, right? And then I pop back, and then I do it again. So I'm always pushing the thing, pushing the elements back. Okay. If that is true, okay, so we have nothing. We push back a value, so there's one element on there. Index is now 1. Okay, so we come down, we have 1 index. Then we push another one, now we're at index 2. There's 2 elements in there. Okay. Index should technically be 2. Should I minus 2? If pattern IDX minus 2 equals increasing and result of IDX minus 2 result IDX minus 1. Okay, so this is the valid argument if it's increasing. we want to return false, right? If pattern idx minus 2 equals, should be else if. D one value is wrong. 1, 2, 3, 5, 4. This is wrong. But I feel like if this, what if I had this above the value for return false, right? So even if the length is right, I want to return false either way. Like this. Ooh, a lot faster. Okay, let's get rid of this for loop. Cool. Okay, so if result.length equals pattern.length plus 1, then it's true. We've already checked every node for the condition. This condition, I'm not even sure if this condition is valid anymore. It's not. So we don't even need to check this condition at all because we fixed it here. We were getting different values, but the index is always going to be tied to it now, right? Okay, so that's good. Okay. Can't think of anything way to make it faster. We've already made it considerably faster than it was, though. Okay. This is going to be my solution, then. Oh, look. We're at the top branch now. Cool. So basically, this was pretty much a simple backtracking and checking problem, right? We place a value. We check to see if the value is valid when applicable. If it is not valid, we end up just returning false. And then we basically check every possibility and then rapidly return if it's not. So, okay. No. Let's see. If this returns true, I wonder if I can say else return false. I mean, I return false here. No, because if it returns false, I want to pop back and keep going. Yeah, so this is perfect. Okay, cool. Yeah. So this was today's problem. I hope you enjoyed. I hope you all have a wonderful day. Thank you for joining me. Subscribe if you want. Peace.